vegetation index, which is used in land use change and agriculture. You know, how green is your green? Your vegetation. The last one here is image classification toolbar. When you bring in your vector, your raster data sets, your pixels all have values for the data that's being displayed. You can clump those into like types of reflectance using a tool called unsupervised classification. The software just goes out and says, oh, all those pixels are at this value, put them into one group. You can do a supervised one where you tell it and create what's called a signature file and have it put it into classes that you specified. This is really useful because you can then reclassify this and use it for change detection over time. Just a real quick, so you kind of know what I'm doing next. Landsat scenes come in with 7 or 8 different bands of data, and sometimes you see the word bands and sometimes you see the word channels. But really what the sensor is doing, it's collecting data from a very small part of the electromagnetic spectrum, and each of these bands represent the data collected for a very small portion. Now we see 3 of them, the blue, the green, and the red bands, and you can see their wavelengths and their colors, and their resolution is 30 meters. But what comes in more with remote sense data is the ones we can't visualize, that we don't see, that we need some software to help us see. That's all the near infrared, middle, and thermal bands. Not all Landsat missions have the panchromatic, but some of them do, and that's a 15 meter. So the software takes the bands that you want to be visualized and recombines them using the 3 primary colors of blue, green, and red, and the brightness of the pixels, and it does it automatically. So here's just an example. It's brought in 3 bands, the red, the green, and the blue band, so they are visible, but they're in shades of gray or brightness. The software recombines those using the red, green, and blue into a composite so that you can visualize it as true color. So true color, bands 3, 2, 1, false color, bands 4, 3, 2. Why would you want to make it false color? Well, people use this because the reds really indicate vegetation. You can more easily differentiate vegetation from the urban areas using the false color and pseudo color. Is there a question? Well, in ArcGIS 10, one of the nice things, I showed you the clip tool several times. Well, I can clip easily all of my data sets. You can see how large that Landsat image is. I put it on a backdrop of Southern California. This happens to be a study area in San Fernando Valley. So I don't have to manipulate this huge data set with all of my analysis, which really speeds things up and makes things easier to transport. Where did that tool go? Remember this little search button. So search dockable windows, have it pop out, type in clip, fill it in, and it's easy to clip your data and create new data sets. Here's that image analysis window. We're going to take it, and I'm going to use it in just a minute to do some processing. A couple of caveats here. The image analysis window creates temp files. So if you really want to save those and use those in other projects, you're going to want to go in and do right-click on it and say export data and save it in the type of raster format you want to save it. If you want it to be a permanent data set from the beginning, you can use the clip tools that I showed you, and those you give a permanent name and location. So we're going to go to